I hope all of you are doing well. In today's session, we're going to be discussing some basic concepts regarding right circular cone. We are going to be studying about what is right circular cone, its dimensions. Okay, we're also going to be talking about its curved surface area, total surface area, and also how to find out its volume, right? But first, before moving forward, let us have a look at a glance what are all things we are going to be covering in today's session. Okay, we're going to be covering about its dimensions, CSA, that is curved surface area, TSA, that is total surface area, and we are also going to be having a model in which we are going to be visualizing the total surface area of the cone by using a 3D model, and finally we are going to be finishing it off with talking about volume. All right. Now, right circular cone, all of you must have seen, like you must have seen birthday caps, right? Ice cream cones. So what is it? Okay, it has a circular flat bottom, all right, and a pointy top. All of you must have seen a hat, like the birthday hat or a birthday cap. So that is an example of a cone. Now it has a radius of its base, the distance from the center of the circular base to its edge, that is the radius. We have a circle at the base, right? It also has its height, right, and also has its slant height. Slant height is the curved height. Got it? We are also going to be looking at all of these dimensions by using our 3D models, don't worry. Now, how to find the curved surface area? Curved surface area, as the name suggests, is the surface area which is curved, right? Not flat, it is curved. So all of these things, so let us quickly talk about with using our 3D models for our better understanding. Now, first let us look at the dimensions of the right circular cone. All right. So here you can see in the model, we have its h. Okay, we have the h as height, the height of the cone. Okay, let me point it out again here also. Okay, this is the height of the cone. Now slant height, as I was talking about, it is the curved height, or you can say the height, again, as the name suggests, the height which is slanting, right? This is the main height or altitude. Okay, this h is also called height or altitude. Okay, it is a perpendicular distance from the bottom which rises vertically from the ground surface, that is the altitude. Okay, now L is the slant height. L is the slant height, and R is the radius of the bottom circle or the base circle. Okay, just a moment. Let me tilt the model so you can see easily. This one is the radius. Okay, as I am tilting the model, you can see the bottom of the cone is made up of a circle. There is a base circle, right? Now how can we find the curved surface area of the cone, right? So to find out the curved surface area of the cone, what we have to do is we have to cut open the cone from the middle. Okay, and it is going to be looking like the sector of a circle. Okay, it is going to be looking like the sector of a circle. This is a full circle, right? Now the cone, when cut open, it is going to look like the sector of a circle. This will easily be understood when we are going to be looking at our further models, that is visualizing the surface area of the cone. There you will easily be able to understand how the cone can open up and it can give us the sector of a circle. Sector is just a part of a circle. Got it? So the curved surface area of a cone is given by the formula, that is pi RL. Pi times R times L. Now L here is the slant height. L is the slant height here. Now let us talk about total surface area of the cone. Okay, how are we going to be finding out the total surface area? Now total surface area of the cone will be given by the curved surface area plus the area of the base circle here. You can see the area of the base circle here plus the curved surface area is going to give you the total surface area. Okay, let me write it down here in short. The total surface area TSA will be given by the curved surface area plus the area of the base circle. Okay, now curved surface area we have already found out. The curved surface area is pi RL, pi times radius times slant height. Now we just have to add the area of the base circle. Now area of the base circle is how much? Area of the base circle is going to become pi r square. Okay, so pi RL plus pi r square is going to give you the total surface area of the cone. Now students, let us visualize the surface area of the cone by using a very interesting simulation where we can easily be able to change the parameters like slant height, like radius, okay, and we can solve a few questions regarding that. Okay, now here we have a cone with us whose slant height is given as 3. Let me rotate the model so you easily will be able to see. Okay, whose slant height is, you can see it is 3, and the radius of its base is 2. Okay, slant height is 3 units and the radius is 2 units. Now we have to find the total surface area of this cone. We can easily use the formula, right? But let us first visualize how actually we find it out. Where did that formula come from? Let us open the net first. Okay, as you can see the black horizontal line, from that part the net is going to open, and from 3D structure it is going to become a 2D structure. Slowly I'll be sliding the slider on the left. You can see the base circle is separating out, right? You can see the base circle is separating out, and slowly the curved part is straightening itself out, right? So it was a cone before, now it has become a 2D net structure. Now remember students, we talked about how the curved surface area when straightened out, it becomes the sector of a circle. Sector, remember, sector is the part of a circle. Okay, now since it has become a 2D structure, easily the area can be calculated. Surface area is lateral surface area plus base area. Lateral surface area is none other than the curved surface area, which is pi RL plus pi r square. Now when we replace the variables, now this 3 and 2 will be put into values, and it is going to become 10 pi square units. Shall we do it with a new cone? Let us have a new cone with us. Okay, another cone. Now here some slight changes are there. This time the base radius is 5 units and the slant height has become 6 units. Let us again open the cone. Let us again open up the cone. Slowly, as you can see, it is opening, and again it is going to become a 2D structure, net. Right. Here you can see that the base circle has a radius 5, okay, and the slant height becomes the radius of the upper circle or the upper sector. Okay, so when we replace the variables with the actual values here, the answer becomes 55 square units. Let us try it out with a third new cone. This time this cone is a little bit longer, right? So again let us open it out. This time the slant height is 3 and the base radius is 1 unit base radius, and slant height is 3 units. Let us open the net again. Got it? So here we get a small circular base. Okay, that was previously obviously 2D structure. Its area can be easily calculated out, and the red part is now showing us the 2D version of the curved surface area. That is again it is a sector of a circle. Alright, and when we replace the variables, again 4 pi square units. Now to find the area of the sector of a circle, see, finding out the area of a sector of a circle is really simple. What we have to do is, since we are taking a part of the circle, we just have to find the entire area of the circle and multiply it with the part which we are actually finding it out. Okay, the actual formula is theta by 360 times pi r square. Okay, where theta by 360 will give you the part of the sector. Okay, but that into that territory we need not go. We can just apply the formula here. Pi RL is the curved surface area, that is the area of this sector, and pi r square is the base circle's area. So together it is going to give us the total surface area of the cone. All right. Now let us talk about finally the volume of a cone. Okay, the volume of the cone is given by the formula that is 1/3 pi r square h. Okay, the volume of the cone is given by 1/3 or 1/3 of pi r square h. Now remember whose volume's formula is pi r square h? Pi r square h is the volume formula of cylinder. Okay, so volume of cone, you can remember, it is 1/3 of the volume of the cylinder of a same height. Okay, here you can easily remember this way. 1/3 pi r square h is the volume formula of a cone. Again, the dimensions will be same. H is standing for height, all right, r is for radius, and L is for slant height. Okay, now here actually slant height is not required. Only for finding out volume we require height of the cone, that is the altitude of the cone, and the base radius. Got it? Now let us have some brain buster questions from this topic. Now a very easy question. How do we calculate the curved surface area of a cone? Right? Is it pi r L? Is it pi r square? Or is it pi r L plus pi r square? The answer is going to be pi r L, pi times radius times slant height. Right? Now what will be the formula for the total surface area of a cone? Is it pi r L, pi r square, pi r L added with pi r square, or none of the above? The answer is going to be option, that is pi r L plus pi r square. Now another easy question. Find the curved surface area of a right circular cone whose slant height is 10 centimeters and base radius is 7 centimeters. Now students, here we can put the value, put the formula, that is pi r L, right? So pi, we can take the value as 22/7 multiplied by its base radius, that is 7 centimeters, and also with its slant height, that is 10 centimeters. So 7 and 7 can cancel out, right? So 22 times 10 will become 220 centimeters square. Now square units we have to mention because we are finding out the area, right? So that will be all for today's session, students.